Hello students, as we were discussing about sound, and in my last class I said that the sound, just like light, obeys refraction. Okay, follows the rule of refraction. That means whenever the sound travels from one medium to another medium, it changes its path. Okay, until and unless it is incident normally. So which is similar to the case as we see in light. Okay, so and also when sound wave travels from one medium to another medium, its speed changes, its intensity changes, its wavelength can change, but the frequency will remain same. Frequency can never change. Okay, uh, let's talk about the uh, difference between the sound wave and the electromagnetic wave. What is electromagnetic wave? Light is an electromagnetic wave. In our previous class, when we studied chapter light, you understood the characteristics or the properties of electromagnetic wave. Okay, now we are studying sound waves. So what is the difference between them? Okay, are they same or is there any difference? That we'll study now. So electromagnetic waves, which can be either gamma rays, X-rays, ultraviolet rays, visible rays, infrared, microwaves, these are all, this comes under, all these waves comes under electromagnetic waves. So in our last class, as you learned, that electromagnetic waves consist of electric field and magnetic field, both are perpendicular to each other. Let's say this is the direction of, electric field. Okay, this pen shows the direction of the propagation. That means towards this direction the electromagnetic wave is propagating. Then the electric field and magnetic field will be perpendicular. I'm sorry, let me get this pen. Okay, if this black pen shows the direction of the propagation of the electromagnetic wave, then this would be the electric field and this would be the magnetic field. Okay, and this is the direction of propagation. So both electric field and magnetic field will be perpendicular to each other. That is, they will be mutually perpendicular to each other, and they will be perpendicular to the direction of propagation as well. This is the perpendicular between the direction of propagation and the electric field, and this is the perpendicular between electric field, magnetic field, and the direction of propagation. So that's what we studied. Okay, you saw the clear graphical picture. Okay, I have shared the YouTube video where you saw the uh, graphical picture of the transverse electromagnetic wave. So therefore electromagnetic wave is called the transverse electromagnetic wave, because electric field and magnetic field are perpendicular to each other, as well as direction of propagation. That is, electric field and magnetic field vibrates perpendicular to the propagation. Therefore it is called transverse wave. And one thing you also know that electromagnetic wave is only transverse in nature. It cannot be longitudinal. Okay, but sound wave can be both longitudinal and transverse. Okay, it is transverse only in solids, because for the transverse wave to form, the medium must have rigidity. Okay, medium must possess rigidity, and which is true for the solid. Therefore transverse wave of sound is seen in solid, but the solid can but the sound wave can be both electromagnetic transverse wave as well as longitudinal wave, whereas electromagnetic wave or light wave can only be transverse in nature. Okay, so this is the first difference between the electromagnetic wave and the sound wave. We know the speed of the electromagnetic wave in vacuum is 3 into 10 to the power 8 meter per second. Okay, which is maximum, and different medium the electric speed can change. Okay, but it's maximum in air or in vacuum, which is 3 into 10 to the power 8 meter per second. But whereas the speed of sound in air is very less compared to the speed of light, or speed of electromagnetic wave. Speed of sound in air is only 340 meter per second. Okay, which is very less, or 330 meter per second in air. I'm sorry, it is 330 meter per second in air. Now, wavelength of light wave is very small. Okay, wavelength of light wave is very small, which is 10 to the power minus 6 meter, whereas the wavelength of sound is is very large compared to the wavelength of light, which is 10 to the power minus 2 meter to the 10 meter, 10 to the power minus 2 meter to the 10 meter. Therefore the one more thing we have to know here is that the speed of sound needs the sound needs medium to propagate, whereas the light doesn't need any medium to propagate. Light can travel even in vacuum. Okay,